Welcome to the Explainer. All right, so if you're getting into Java, there's this one huge question that always comes up. How do I really know my code is working? Well, today we're going to answer that. We're diving into the world of unit testing with an awesome tool called JUnit.
And we're actually tackling this topic because of a great request from Dr. Sasan Azizian. So this guide is built especially for all of you out there who are learning Java and just want a straightforward, simple way to understand testing. Let's jump right in.
I mean, this is the big one, isn't it? Your code runs, you don't see any error messages, but is it doing exactly what you wanted it to do? How can you be sure? Let's figure out how to prove it.
Before we even get into the nitty-gritty of code, let's connect this whole idea to something from the real world. I promise, this is way more intuitive than it might sound. Think about it this way. You wouldn't just glance at a new chair and assume it's safe to use, right? No way. You'd, sit on it, you test it. It's the exact same deal with our code. We can't just hope it's correct. We have to actually give it something to do and check the result.
So, to do this properly, we don't just poke at our code randomly. We create something called a test case. And really, it's just a simple recipe. We give it a very specific input, and we state ahead of time exactly what the output should be.
And here it is, the moment of truth. Our test runs the code, sees what it actually did, and then compares that to what we expected it to do. If they line up perfectly, boom, you get a nice, satisfying green pass. If not, you get a red fail, which is actually a good thing. It's telling you, hey, look over here, something's not quite right.
Okay, I know what some of you might be thinking. Isn't this just a bunch of extra work? Well, let's talk about why this extra work is really a safety net and why it's going to become one of your best friends as a programmer.
You see, these things are all connected. When you find bugs early, before anyone else does, you feel way more confident changing your code later. And why is that? Because you've got this safety net of tests that will scream at you the second you break something. Plus, your tests kind of act like documentation, showing exactly how the code is supposed to work. And when you add it all up, you save a massive amount of time.
Okay, so to really get the big picture, we need to see where these unit tests we're talking about fit into the grand scheme of things.
People often talk about this testing pyramid. Way up at the top, you've got these big system tests that check the whole application. A little lower, you have integration tests that see if different pieces play nicely together. But what's holding it all up? A huge, solid base of unit tests. They're small, they're super fast, and they are our foundation. That's our focus. And that's exactly where we're digging in today. A unit test is all about putting one tiny piece of your code, usually just a single method in Java, under a microscope. It's like checking every single brick to make sure it's perfect before you even think about building the wall. So how do we actually do this in Java? Well, the good news is we don't have to invent the wheel. The Java community has an amazing standard tool just for this.
Let's meet JUnit. Honestly, it's the standard. It is by far the most popular, most powerful framework out there for unit testing in the Java world. It gives us all the structure and the special commands we need to write great tests and fast.
Now, if you only remember one thing about JUnit, make it this: the @test annotation. In Java, an annotation is basically just a special tag. You just type @test right above a method, and it's like putting a giant neon sign on it that tells JUnit, hey, this one's special. This is a test. You need to run it.
And here's the best part. Writing tests isn't some complex, mysterious art. Nope. Pretty much every good unit test you'll ever see follows the same super simple three-step pattern. Let's check it out.
It's called arrange, act, and assert. That's it. You set things up, you do the thing you want to test, and then you check the result. It's a clean, simple recipe for every single test.
Okay, here it is in some actual code. Let's pretend we have a calculator class with a simple add method. This little block of code you see here, that's a full-blown professional unit test. Let's break down exactly what's happening step by step. First up, arrange. This is all about getting your ducks in a row. For this test, all we need is a calculator object, so we create one. If we need anything else, more complex data, other objects, this is where we get it already.
Second, we act. This is the main event. We call the one specific method we're interested in this case add, and we save whatever it gives us back into a variable. This is the part where we actually run our code.
And finally, we assert. This is our check. We use the special assert equals command that comes from JUnit. And we're basically saying, hey JUnit, I fully expect the answer to be 5. Is the actual result we got also 5? If they match, the test passes. Simple as that.
All right, we've written the test. Now for the fun part, actually running it and seeing that magic happen, getting that instant feedback.
And you know what? Our modern code editors, our IDEs, make this incredibly easy. Usually you just right-click the file, hit Run Tests, and bam, you get an instant report card. A green bar means you nailed it, a red bar means you found a bug. It's that simple.
So let's pull it all together one last time. At its heart, a test is just proof that our code works. We do it to catch bugs early and, just as important, to feel safe when we change things. The rock-solid foundation for all of this is the unit test. For us Java developers, our tool is JUnit. We flag our tests using @test, and we build them with that simple, powerful pattern: arrange, act, assert.
Look, this isn't just some academic exercise. This is a real-world skill you can start using today to write better, more reliable code. You now have the power to actually prove that your code works. So my question to you is, what's the first bug you're going to go catch?